Okay, so on our third video, it's very related to what we just did. What we just did by hand, we are calculator. All right, and what we're doing is quadratic regression. And what does quadratic regression do? It finds a model, a quadratic model to fit a given data set. So, and talk about why we care about, we can't just do linear regression that we did in Algebra 1 for the rest of our lives, because some data set, like if I did linear regression and I find that went best fit of data through this, it would be an equation that showed you, and we can clearly see that this data does not represent a constant rate of change. We see the rate of change faster, slower, slower, slower. I mean, we need a quadratic equation to represent this set of data. Okay, so I can determine the equation of a quadratic from a set of data using a calculator, and I can determine if a line quadratic is a better fit for the set of data. Okay, so here we go. Sketch a quadratic that you think is the data model. Well, obviously, I would just draw a line right through it. There's a quadratic with a vertex, like, I don't know, 17.5, 6, right? And that has intercepts here. That would be my best guess. A better way. All right. Determining a model by hand is not efficient. We just did it with 3 points, and it was a lot of work. Since each person would estimate what they see. They're saying that this drawing is not good because we could each be slightly off. The way we did before is just the calculator has regression features that determine the best model for a set of data. So the first thing we have to do is make sure diagnostics are on. So here, follow me carefully. So clear out your calculator. Now, let's see, get that one. Here we go. You want to hit the blue key and you want to go catalog button. Okay, hit the button and you should get a catalog of all the features in the calculator. Scroll down till you hit the D. Scrolling, getting to D's. I've got to D. Now go diagnostic on. Go to diagnostic on, hit enter, and hit enter again if yours says off. Okay, or clear the calculator. Now, enter some data into list 2. So, steps as we go through them. Edit. Actually, no, we're not going to do that because I don't want to turn the page back. Let's box them in. We do the stat key. We hit the edit the one edit key, and then and there's where we enter data into list 1 and list 2. Right? Then we want to construct this scatter plot. So we have a calculator to scatter plot. So we hit the second, clear it, we hit the second button and we go up here to y equals, and you see the blue key, that's stat plot. So hit stat plot, and then this plot is probably on your calculator off. We want to turn it on, and you make sure that, go back and forth, it's on. Now you can do different types of graphs. This font, we don't want a bar graph or a histogram. Okay, and check your lists. It should be, okay, that's the plot graph on. Okay, and that was the second button, Y1, and okay. When we want to see this graph, what we do is zoom feature, zoom down to 10. Excuse me, zoom 9, stat fit. Now it's saying invalid because but zoom 9. Okay, so zoom 9. Okay, shows us the graph. Right. Want to find our equation, right? This is finding the equation. We do stat, calc, and we choose regression. Okay, more carefully when we do it, but we are going to store the equation 1. We want to compare things. It's already in our, and that's a neat feature. So use this series vars, y-vars function, y1, and this will seem more clear when we actually do it. Okay. This is 5 clicks. Okay? All right. How well, because we said we need a linear function or a quadratic function, to determine how well data, the best correlations, -1 and +1. Negative 0.8 and is considered to be a pretty good correlation. The closer it's to 0, the worse. Meaning, if or closer to -1, it's pretty good. If it's 0.8 or closer to 1, it's pretty good. If it's 0.5, it's not a good correlation. Quadratic regression 0.5, you would say that a quadratic model is not the best. So let's do it. So turn the page. We're going to do the process. So here we go. We want to enter, okay? So we've got this data. These are the X's, are the Y's. An engineer speed of a Ford Taurus and its average miles per gallon. So this is going to be our graph. So let's put on the X-axis the speed of the Taurus. Okay, and on the Y-axis we're going to show the average per gallon that the Taurus is getting. Okay, so sketch of the scatter plot, determine a model for the data. So let's use these points to sketch. Okay, first 30, 18. So go 30, Y is 18, 35, 20, 35, 20, 40, 23, X is 40, Y is 20, 45, 25, 50, 28, 55, 30, and 60 coming down, 29, and 26. So we've sketched a plot of the data. Regression model. So here we go. In this data, hit the stat button. We want to edit. So hit enter. Now, if you in your calculator, what you need to do is scroll up to the top where it says L1 or L2 and hit entering in 35, enter, 40, enter. Okay, so enter all these 40, 50, 55, 65. Go enter the Y's, move over. So you move over to put them in. Putting the right data in because not the right data, not the right answer. Now, one thing in your data, before you move off the same number of X's as I do Y's. And if you don't, then you need to recheck. Okay, now we're going to hit, and we want to find the regression model. So we go to now, we go scroll down to quadratic regression. So you're on quadratic. You're taking data from list 1 and list. Now, store regression. This was our 5 clicks, okay? It's on the back page if you want to look at it. You want to hit the variable button. You're storing information in a variable. So here, hit the vars button. Over here to the Y vars. There you go. Now, you've got, it's already highlighted on the 1. So you hit, whoops, Y vars, function, enter, in the Y1 in our calculator. So it's on Y1, so hit enter again. It's going to calculate the equation and it's going to put it in your Y equals Y1 place in your calculator. So all right, so hit enter. Now, what have you got? You've got C, and that was a lot faster, 3 points. And look at this R. R squared, because it's a quadratic, 0.92 tells me this is a pretty good correlation, right? It's closer, it's very close to 1. By the way, anybody needs to, please go back, stop the video and go back and make sure that it was able to store that equation. You're welcome to stop the video and go back. Okay, so we've got that. Now let's write an equation. So over here, A is negative 0.0. I'm going to round it to the third decimal, right? 0.16. B is 0.813. Negative 23.161. All right, so what I'm going to do is write y equals negative 0.6x squared plus 1.813x minus 2.161. The equation for this data set. That is the line of best fit. Okay, so let's write down our R value was equal to 0.93, okay, just in case we need that later. That's what our R value was. So this is a good model. Okay, what do we do with it? Let's read these questions. The maximum speed of the Taurus is 120 miles. I hope none of you ever go 120 miles. Use your model to determine the gas mileage for the maximum speed. So what am I going to do? It's an x value, right? Because these are all. So let's do that. We've got, go to y equals, got the equation, and the calculator puts the equation in, like, let's look at it, so it's very accurate. I want to be careful about is what's my window? I've changed it already, but please change to your window and make sure, if you're going to check a value of 120, it's got to be in your screen. Go to the window, change the x max to 120, change the scale, and then all right? So we've done that. Now we're going to say, let's calculate what is the miles per gallon when the speed. We're going to do second calc. I'm going to check the value. It shows us our. What's something else that we're going to do later? Never mind that line. X equals y value. So let's write that down. What is the gas mileage? That would be negative 0.3 miles per gallon. Is that reasonable? Miles per gallon? No. Right? We can't negative miles per gallon. So it's not reasonable. Right? The gas has to use gas. We have to have some miles per gallon. All right, so that is not reasonable. So we have to discuss and the range for this function. So we think about what's reasonable. So the x-axis is speed. What are reasonable, right? The domain is the x-axis, and it's what are reasonable speeds. We can't go speed, so 0 is the domain, all the way up to, well, we'll say 120. Please never go that fast. Okay, the range, average miles per gallon. So that's R, Y, MP. Well, we can have 0 miles. What's average? We usually get 20, 30. What is the best we could do? I mean, or something. I don't know. Well, let's just say that the best was like 60 miles. It's about a reasonable range. And I'm just thinking here. So that would be my domain and range. According to the model, at which speed gas mileage be maximized? That's right there, right? At which speed? Well, at that, the miles per gallon. Okay, but that's not accurate. This was a sketch. Let's do it on our calculator. So we've got this graph, y equals, I'm going to erase this for now. All right, and we've got our graph. Calc max 4, and this is a left bound, right bound thing. Left bound, so I move my 73. I'm going to move it. It says left bound, so I go up to the max. Remember how to do this? Left like 5 or 6 times. 1, 2, 3. I am left of the maximum. Enter. I go back to the max. There I am at the max, and I go right a few times. 1, 2, 3, 4, 5. Enter, enter. Okay, the maximum occurs, let's write it down, at 56.8 value. The y value is 20. Let's round that off, 4. So the question says, at which speed would the gas mileage be maximized? And that would be at 56.8 miles per hour. Okay, that's the answer to that question. All right. Determine the residual 45 miles per hour. Also, you probably forgotten it. This is just a small thing, that's why. All right, residual equals value from the table minus the predict from the equation, okay? So we're just going to plug it into this formula. The residual equals. Now, what is the miles per hour? Well, we go up to the table. The actual value is 25 miles per gallon. That's the actual. So we say 25 minus the predicted. Well, I need so I go to the equation and I say calc value. I'm going to calculate a value when x is 20, right? Value, wait a minute, do I have that backwards? Actual minus predict value. This model is the predict I'm doing.